Hello and thank you for joining us. Today we will be repeating the previous lesson of an engine heater/cooler, but instead of using state machines, we will be using activity programs. Activity programs are logical flow diagrams similar to state machines. However, unlike state machines, they have a defined start and end point, so they are not constantly running. Like in the last example, I already have a temperature value as well as a heater and cooler state. Let's start by naming our program temperature check and adding a start block, which must be present in every activity program. Next, we are going to add and connect a multi-decision block, which enables us to test our various conditions in sequential order until one returns true. Let's add 3 decisions blocks in addition to the default option, which is always true. Let's set the first condition to be true if the temperature is ever equal to or over 150 degrees. Let's set the second condition to be true if the temperature is ever equal to or lower than 40 degrees. And finally, let's set the third condition to be true if the temperature is between 45 and 145 degrees. If none of the cases above are true, then the default case will execute. Next, let's add and connect an action block for each possible condition. The first condition is true if the temperature is high, so let's have this action block turn on the cooler. The second action is true if the temperature is low, so let's turn on the heater. The third action is for when the temperature is in the acceptable range, so let's have it turn both the cooler and the heater off. We have built in a deadband where no action will be taken when the temperature is between 41 and 44 degrees, or 146 and 149 degrees. During those temperatures, we want it to maintain its current state. So if the heater is on at 42 degrees, we will want it to stay on. But if it is off, we want it to stay off. In these conditions, the default case will execute and it will have no actions connected to it. Finally, let's add a stop block to conclude the activity program and add connections from all 3 actions as well as the default case. Before we are ready though, we need to create a run on event to fire this activity program. Let's name it temperature check activation, and we want to add an associated timer to run this activity program every second. Now if we open up the remote view, we can see that it behaves as expected. Turning the temperature down will turn the heater on, and it will stay on until the temperature returns to correct levels. The same is true of the cooler. Before we conclude, let's review some of the other features of the activity program. The multi-decision block, which we have already used, operates much like a case statement in programming. We have demonstrated using it with a multi-value variable, but there is another handy feature when using it with an enumerated value. Select the variable you wish to use. For this example, let's pick day-night. Then in the switch window, select Auto-Create, and it will automatically populate the states defined in the enumeration tab for that variable. We could have used individual decision blocks to accomplish the same thing, and branch them one after another as shown here. Don't forget to name each block so it is easy to follow. Use the note blocks to explain the logic. Since the actions and variable changes are executed at the end of the activity program, if you need a variable or action to be taken before proceeding, you can break that section into a separate activity program and call it in the activity block. This is also useful to break apart a large program into what could be considered subroutines. The internal message block makes it very convenient to set a standard DM1 style of fault code. For example, if you are measuring a temperature sensor on an analog input and wanted to generate a high temperature fault message. This gets passed to the diagnostic message application and will be processed just like an incoming fault message on the CAN bus. It will also auto-generate this message whenever this block is reached. The Add List Item block allows you to bind the block to a list and add an item. You must bind this block to a specific list and then choose a specific variable to add to the list for each column. It will automatically create a new list item out of all of the variables listed and add it to the list. Thank you for joining me, and for more tutorials, please visit support.innovationcontrols.com.